a question like this yesterday in class. So it's asking us, right, the pH is the unknown. We have an initial concentration, 0.067 molar acetic acid, and they tell us that the Ka for acetic acid is 1.8 times 10 to the minus 5. So for acetic acid or any generic weak acid, right, it's going to react with water to form hydronium and the conjugate base, which is acetate. So our Ka expression for that is, right, concentration of hydronium times the concentration of acetate conjugate base all over the concentration of acetic acid, CH3COOH. And yesterday we made the assumption that, right, setting up our ice table and thinking about how we're going to set up our ice table, we know our initial concentration of acetic acid is 0.067 molar. We don't know our hydronium concentration. We don't know our acetate concentration, but they should be the same, because for every 1 molecule of acetic acid that ionizes, I'm going to form 1 hydronium and 1 acetate. So they're formed in the same ratio. So I don't know those concentrations, but I could call both of those concentrations X. In our normal equilibrium ice table, we have to subtract something from our initial concentration. But for all the acid-base questions we're going to look at, we're going to see that basically the initial concentration is large enough that we can ignore subtracting that X and just kind of make our life a little bit easier, so that our ice table would come out being, acetic acid, hydronium, conjugate base. All right, basically my equilibrium concentration is going to be the same, my initial concentration for that. Here's X and here's X, and I already know Ka. So plugging in Ka, 1.8 times 10 to the minus 5 equals X times X all over the concentration of my acid, 0.067. I'm going to multiply both sides by that. Sorry, I'll try to keep this vertical so it doesn't flip. Yeah, no, I know. Thank you, Gary. I know I'm old, but I'm not that old. 1.8 times 10. So is that going to show up in the survey, the Partnership for Inclusive Excellence? Dr. French doesn't know how to lock his iPad screen and it flips around. 7. So I get X squared equals 1.206 times 10 to the minus 6, right? Square root of both sides. And I get X equals 1.098 times 10 to the minus 3. What is X, right? X is my hydronium concentration. So negative log of that to get the pH, right? pH is the negative log of hydronium. And that's the challenge for a lot of these pH calculation questions, is this was kind of the main calculation we were doing for equilibrium. We're not done there, because I found X, I found my hydronium concentration, but the question is asking me, what is the pH? So had to find X. pH is the negative log of hydronium, 1.098 times 10 to the minus 3. All right, negative log of that. And I get like a 2.96 for the pH of that. So we'll see a lot of questions like that where Ka, initial concentration of the acid, what's the pH? In all those cases, we're going to be safe in just saying the concentration of the acid and the conjugate base, I don't know either. They're both X, they're both the same concentration. So we can just solve for X, one of those X's is hydronium, so now I know hydronium negative log gives me the pH of that solution.